In this video, we will learn how to prove that two triangles are similar.
There are three different ways to prove that two triangles are similar. One is side-side-side similarity. If all three pairs of sides are proportional, that just means they're going to all make the same ratio if I make fractions out of them. For example, 10 over 5, 10 and 5 are corresponding sides, and if I do 10 over 5 as a ratio, I get 2. 6 and 3 are corresponding sides, and if I do 6 over 3, I get 2. 12 and 6 are corresponding sides. If I do 12 over 6, I get 2. So this is what it means when I say all three pairs of sides need to be proportional. So that would be side-side-side similarity. By the way, these three ratios that all turn out to be the same, this is called the scale factor. So we would say the scale factor is 2. All right, and in this context, that means that the big triangle is twice as big as the small triangle. Anyway, in addition to side-side-side similarity, we can prove that two triangles are similar if they have two angles that are the same. Like 65 and 30, the small triangle has degrees 65 and 30. That's enough to prove that these two triangles are similar. And the third and final way to prove that two triangles are similar is side-angle side similarity. The S and S again refer to the sides being proportional. So I used the same number, so we've already done the math, but these are still proportional, meaning that the 10 over 5 equals 2 in the same way that if we've got the 12 and the 6, again 12 over 6 equals 2. So we have two pairs of sides that are proportional, and then one angle that is congruent. It's important that the angle that is congruent is between the sides that are proportional.
So when you look at problem number 3, you see that these lines are parallel. So you've got parallel lines cut by a transversal, well, two transversals, and when that happens, corresponding angles are formed right here, and if the lines are parallel, corresponding angles will be congruent. So these angles are congruent. Similarly, over here we've got another pair of corresponding angles. Now, two pairs of corresponding angles right there, that's enough to prove that the triangles are similar. But actually we know all three because this angle is a shared angle for both the inner triangle and the outer triangle. So angle B will be congruent to angle B by the reflexive property. So you can pick any two pairs of angles and use that to explain why the triangles are similar. So I think I'll just use the corresponding angle explanation. Alright, so here I've said that angle BDE is congruent to angle BAC, so these two, and angle BED is congruent to angle BCA, so these two are congruent. And of course, like I said before, that's because if the lines are parallel, corresponding angles are congruent. So I'm going to go ahead and make this similarity statement, but I'm going to then say by the angle-angle similarity theorem. So that's another part, it's still part of the explanation. So now I can say that triangle BDE is similar to triangle BAC by the angle similarity theorem. Okay, so it's all part of the explanation, and I did mention the similarity statement that they asked us for. Okay, for number 4, we are given that the outer triangle is similar to the inner triangle. We're just asked to write a statement of proportionality. Alright, so that's where we just sort of match up corresponding sides and make fractions out of them. So for example, so let's start with the vertical piece. So I'll go big over small here. So I could say BA over DE, because those are corresponding. Okay, big, small. I could go BC, alright, it's the large side, and then DC is the corresponding smaller side. And then on the bottom here I could go AC for the bigger one, and then EC for the smaller one. So that's a statement of proportionality. Alright, for number 5, these two triangles are being described. I feel like I need to draw them so I can see what we're dealing with. Alright, these will not be to scale because I don't even know exactly what the numbers are doing yet, but I'm just going to write them down and worry about it later. So MNO. Alright, so this could be MNO. And EFG. So EFG are similar. With angle M is congruent to angle E. Okay, so that's all lined up. N is congruent to F, just like you would want. Okay, what else? MN, NO, and MO are 6, 8, and 9. Okay, so MN is 6, NO is 8, 6, 8, and MO is 9, 6, 8, and 9. EF is 7.2, so this is 7.2. So then it says find FG, and FG is right here. Now let's look at corresponding sides. Alright, the 6 and the 7.2 are corresponding sides. And the 8 and the X are corresponding sides. So I can set up my proportion. Alright, I can say, for example, 8 over X is equal to 6 over 7.2. Alright, left, right, left, right. So then it's just a matter of solving this proportion. So if I cross multiply, I'm going to have 6x along this diagonal, and then 8 times 7.2. So that's 57.6. And then we would divide by 6 on both sides. And you get 9.6. Alright, so that will be the length of FG. Okay, let's look at number 6. Alright, we are given that AC is parallel to DE. So that means these are parallel. Alright, we're trying to prove that the inner triangle, ABC is the outer triangle, DBE is the inner triangle. And we're trying to prove that they're similar. Now, speaking of similar, this is similar to this problem that we did a moment ago, number 3. So we really are doing the exact same thing as a more formalized proof. But the bottom line is going to be we've got corresponding angles here, and if the lines are parallel, then corresponding angles will be congruent. We've got more corresponding angles over here that we could use. That's already enough to prove the triangles are similar by the angle-angle similarity theorem. But if they decide to go another way, we could use the reflexive property and say that angle B is congruent to angle B. So I'm not sure which pair, because we've really got all 3, but they only need 2. So I'll just leave it all marked for now. So that's our strategy. So clearly we're starting off with a given here. AC is parallel to DE. That was simply given. Now angle ABC is congruent to angle DBE. Let's see. ABC is congruent to angle DBE. Well, they're just naming this angle 2 different ways. Alright, ABC and DBE. They could have said angle B is congruent to angle B without being ambiguous. Either way, this is the reflexive property. Alright, that angle will be congruent to itself. Now, here they say angle A is congruent to angle BDE. So angle A, of course, is right here, and then BDE is this right here. So those are the corresponding angles we were talking about. So we will say if lines are parallel, corresponding angles are congruent. Okay, so that's what they went with. They went with the reflexive one and one of the pairs of corresponding. So they went with these. Alright, and that's enough, because now we can say that the 2 triangles are similar by the angle-angle similarity theorem. And that is how you prove that 2 triangles are similar.